Welcome to the DIY Honda Garage channel. DTC P2096 is indicative of a post-catalyst fuel trim system too lean condition in the Honda Civic models from 2011 to 2015. This Diagnostic Trouble Code DTC relates to the vehicle's exhaust system and fuel management performance. A lean fuel trim means that there is insufficient fuel in the air-fuel mixture after the catalytic converter. The key components involved are the air-fuel AF sensor and the secondary heated oxygen sensor, HO2S, which are critical for monitoring and adjusting the fuel mixture for optimal engine performance and emissions control. The AF sensor is typically located upstream of the catalytic converter and plays a crucial role in reporting the air-fuel mixture to the Engine Control Module, ECM. The secondary HO2S, on the other hand, is located downstream of the catalytic converter and monitors the efficiency of the catalytic converter. Together, these sensors help maintain the vehicle's emission standards and fuel economy. In the context of DTC P2096, it is vital to understand the specific roles of the A-factor sensor and the secondary HO2S. The air-fuel sensor, Sensor 1, is crucial for adjusting the air-fuel mixture before combustion, ensuring the engine operates efficiently. Positioned before the catalytic converter, it provides real-time information to the ECM about the mixture, allowing for immediate adjustments. This location is significant because an improper reading can lead to a lean mixture situation. Conversely, the secondary HO2S, Sensor 2, monitors the exhaust after it passes through the catalytic converter. It checks the efficiency of the converter in reducing harmful emissions. For proper function, both sensors need to be in good working condition. If either one is faulty, or if there is an exhaust leak, the engine performance can be adversely affected, leading to DTC P2096. Several factors can lead to the triggering of DTC P2096, each warranting careful scrutiny. First, exhaust system leaks are a primary concern. Any leak between the AF sensor and the secondary HO2S can lead to inaccurate readings of the air-fuel mixture. This situation often manifests from gasket deterioration or cracks in the exhaust. Next, the AF sensor may be faulty. If it malfunctions, it won't provide accurate readings to the ECM, resulting in incorrect fuel management. Secondary HO2S issues can also arise, causing discrepancies in readings regarding the catalytic converter's performance. Lastly, various fuel system issues, such as clogged injectors, may contribute to a lean condition, leading to the setting of DTC P2096. Each potential cause must be investigated to effectively isolate and address the problem. The presence of DTC P2096 is often accompanied by several noticeable symptoms. Firstly, drivers may experience reduced engine performance, as the lean condition can lead to insufficient power output during acceleration or load conditions. This deficiency is particularly evident during situations when extra power is required, such as climbing hills or merging onto highways. Alongside this, increased fuel consumption is a common symptom. A lean mixture can lead to the engine compensating by increasing fuel flow in other areas, ultimately diminishing fuel economy. Additionally, the vehicle may exhibit signs of engine misfire, often related to improper fuel-air mixture being supplied for combustion. This misfire might be intermittent and could occur under specific driving conditions, further complicating the issue and making diagnosis imperative. The first step in addressing DTC P2096 involves a verification process using the Honda Diagnostic System, HDS. Start by turning the ignition switch to the on/I position or pressing the engine start-stop button to enable the electrical systems without starting the engine. Following this, clear the stored DTCs using the HDS diagnostic tool. This step is crucial as it resets the system's history for accurate monitoring. Next, initiate the engine start process and hold the engine RPM at 3000 without any load until the radiator fan activates. This process conditions the engine and allows for accurate readings during the subsequent testing phase. Once the fan engages, transition to idle and prepare to analyze the vehicle's performance under driving conditions defined in later troubleshooting steps. This step sets the baseline for assessing subsequent readings and diagnostics. Continuing with the diagnostics for DTC P2096, it is essential to perform a test drive under specific conditions. Ensure that the engine coolant temperature is above 158 degrees Fahrenheit, 70 degrees Celsius, and that the transmission is in fourth gear. Maintaining an engine speed below 4,000 and a vehicle speed between 15 to 75 miles per hour and 2,000 to 120 kilometers per hour for a duration of at least 1 minute is critical for generating accurate data regarding vehicle operation. After completing this test drive, monitor the onboard diagnostics OBD status through the HDS. This analysis will reveal whether the DTC P2096 shows a failed status or passes under the tested conditions. If the HDS indicates a failure, the next steps will focus on isolating the fault and correcting it. Conversely, a passed status might suggest intermittent issues, requiring a different approach for troubleshooting. Following the preliminary checks, the next troubleshooting step is to evaluate the exhaust system. Begin by thoroughly inspecting for any signs of leakage, which could occur between the AF sensor and the secondary HO2S. Look for visual cues, such as soot marks or exhaust odors, which can indicate leaks. Additionally, assess for potential clogging or blockages within the exhaust system, which may hinder the performance of the AF sensor and secondary HO2S. Blockages could arise from accumulated debris or internal corrosion. If any irregularities are detected during this inspection, it is imperative to repair or replace the damaged exhaust components. Addressing issues in the exhaust system is crucial as they directly impact sensor performance and overall engine efficiency. With exhaust system issues addressed, the next logical step is to check the AF sensor's functionality. Begin by substituting the existing AF sensor with a known good unit. This step helps in determining whether the original sensor was at fault. After swapping the sensors, make sure to securely reconnect all wire connectors to ensure proper communication between the sensor and the engine control module, ECM. Next, turn the ignition switch back to the on, II position, preparing the system for diagnostic resets. Resetting the ECM using the HDS is vital, as it allows the newly installed sensor to function correctly within the vehicle's parameters. The new sensor must undergo an idle learn procedure to recalibrate to the vehicle system settings before further testing can occur. After replacing the AF sensor and resetting the ECM, it is essential to perform another test to evaluate system performance. Start the engine and hold it at an RPM of 3000 without load until the radiator fan activates. Then, allow it to idle. This procedure closely mirrors the conditions of the initial troubleshooting and will help in assessing the new sensor's functionality. Following this, observe the OBD status again via the HDS to check if the DTC P2096 has triggered or passed. If the HDS indicates a passed status, it signals that the newly installed AF sensor is functioning correctly, warranting its replacement with the original sensor. However, if the status reads failed, further investigation will be necessary, including attention to the secondary HO2S. If the attempt to replace the AF sensor does not yield a passing status, Then the focus shifts to the secondary HO2S. Begin by evaluating the performance of this sensor, as it plays a critical role in emissions monitoring following the catalytic converter. Use the HDS to check if the DTC indicates a failed status pertaining to the secondary HO2S. If so, it can confirm that the original sensor is defective and requires replacement. However, if the HDS shows an executing status, it indicates that the parameter is still being evaluated, and ongoing driving may be needed to generate a definitive result. Additionally, if the HDS status indicates out of condition, the process should revert back to the previous RPM hold test to ensure proper reevaluation and data continuity. Upon completion of all troubleshooting steps, it is crucial to conduct a final verification to confirm that the repairs were successful. Begin with a thorough inspection of all connections related to both the AF sensor and the secondary HO2S. Loose or corroded connection points can cause intermittent signals, which may lead to recurring DTCs. Next, recheck that any previous diagnostic trouble codes have been cleared successfully using the HDS software. This ensures that the ECM is reading conditions based solely on current sensor data. Finally, run a diagnostic scan to confirm that no new or existing DTCs appear. A clean slate indicates that all issues contributing to DTC P2096 have been adequately addressed. To prevent reoccurrence of issues indicated by DTC P2096, implementing a routine preventive maintenance schedule is essential. Begin with regular inspections of the exhaust system, checking for leaks or damage that can lead to performance issues or inadequate readings from the sensors. It's important to regularly monitor the performance of both AF and HO2S sensors. Crop detection of anomalies can lead to earlier interventions and prevent serious repairs later. Additionally, incorporate regular maintenance of the fuel system, such as ensuring the fuel injectors are clean and functional. Keeping up with these maintenance actions will significantly extend the lifespan of these components, support optimal engine function, and ensure compliance with emission standards. In conclusion, effectively managing DTC P2096 requires a thorough understanding of its implications for vehicle performance and emissions. A lean post-catalyst fuel trim can severely affect engine functionality, leading to increased fuel consumption and engine performance issues. Following systematic troubleshooting steps ensures that all potential causes, from sensor failures to exhaust leaks, have been addressed comprehensively. Engaging in preventive maintenance is equally essential, as it mitigates the risk of recurrence. By keeping a close eye on vehicle diagnostics and implementing routine checks, vehicle owners can maintain their Honda Civics in optimal condition while reducing the risk of emissions-related penalties. Engaging with this approach instills greater reliability and longevity in your vehicle's performance. Please like and subscribe to the channel. See you next time.